Yeah, one of the things that really enables our science in the modern era in a way that it never did many, many decades ago is the real advances that have come from microscopy and advanced tools in spectroscopy. We now have ways, for example, for doing transmission electron microscopy, aberration corrected, where we can actually image individual atoms at the surface of a nanocrystal. And this gives us unprecedented power to be able to actually understand how the surface structure relates to the chemical reactivity in ways people would have only really been able to dream about even as much as 5 or 10 years ago. That's just one example. But in addition to that, we leverage a number of tools that we have access to both at MIT, at Harvard, and a number of other institutions in the area, in addition to advanced synchrotron techniques that exist at national laboratories like Argonne National Laboratories and Stanford Synchrotron Radiation Lab. And we have collaborations with all of these different facilities to be able to do our science and be able to pick apart these correlations at an atomistic level. One other example that really comes to mind is the significant growth in spectroscopic tools. And you know, we have the power now to do vibrational spectroscopy, to do a lot of nonlinear optical spectroscopies, advanced X-ray absorption and X-ray scattering methods that really have not been possible before. And so these are all the tools that we try to employ now that really people could only guess at what was going on maybe 10 or 20 years ago. And that puts us in a very unique position, but I would still want to stress that, you know, one of the things that really distinguishes our lab is that we're not all about measuring things and we're not all about making things. We know that there has to be that synergy between understanding what's going on and still having the synthetic toolkit to be able to then go in and change that in a systematic way. So while a lot of our program is really sort of guided by our mechanistic studies, our spectroscopic studies, all of these advanced characterization tools we use, it's really enabled by the fact that we have a lot of great synthetic chemists, a lot of people that can make things to be able to modify these interfaces, to be able to make new nanoparticles, to be able to change their surface structure, so that then when you have information, it's actionable rather than just it being information that is sort of left on the wayside.